Hello, I'm JW, and this video is about RCDs, and I've done various videos on those in the past, but in this particular episode we're going to actually look at testing RCDs and the various types of tests that can be done and the sorts of results that you should expect. Now for this demonstration I've just got this ordinary RCD on this test fixture, and this is a single phase RCD, so just got the neutral coming in on this side and the line coming in on this side, and again the terminals on the bottom are basically the same. We've got the neutral coming out and of course the line coming out here as well, and it's a double pole switch inside, so when it's in the off position like this both of these are completely disconnected from the input. Now this particular RCD, as in the case of all of them, has the small test button on here, and then underneath here we've got a small diagram showing the sort of wiring layout inside, and then here we've got the various specifications of this device. First of all here we've got the rated current, which is actually 63 amps. And this is not anything to do with any tripping or overload or whatever. It's simply the maximum current that this thing can safely handle, and so in this case it's 63, and that's really just a function of the contacts inside. Underneath that we've actually got the tripping current, in this case 30 milliamps or 0.03 amps. And further on there we've got this rating here of 6000, which is actually the braking capacity, so in the event of a fault between line and earth, that's essentially the maximum fault current that this thing is designed to disconnect. The rated voltage there, of course, 230 and 50 Hertz, and the making capacity, in this case 630 amps, and essentially that's the situation if there was a fault existing between, say, line and earth or line and neutral, and when it was switched on, that's the maximum amount of current that can flow without actually destroying the device. And then the standard to which it's made here, and the CE mark and so on. And then over here in this very small symbol is the type of RCD. In this case it's an AC, and it's got that small AC waveform inside the rectangular box. And there are other types of RCD, and that's certainly significant when you actually come to test them, because of course you need to make sure you've selected the correct test options. Now for the testing here, I've just got the power coming in at the top here, line neutral going straight into the device, and I've also got an earth connection here on this separate metal terminal block there. And for the purpose of the test I've just got two smaller wires coming out of the bottom here, and I'm going to put those over to these terminal blocks here and here, and a bit of wire hanging out, mainly so it's just easier to connect the test probes to those. But of course normally you'd have this, say, in a consumer unit with a range of circuit breakers along the side, or in the event of just having it on its own it would have a proper enclosure over it, and these wires will obviously go out to whatever load or loads it was connected to. And for the actual testing I'm going to use this Fluke 1653 tester. This is one that has a whole variety of testing functions built in, including the RCD ones which we are looking at today. Of course there are many other manufacturers of test equipment, and of course many other different models as well, but just happen to be using this because it happens to be the one that we've got. However, all of the tests are going to be essentially the same regardless of what type of equipment you're using. The only thing of course is to read the instructions supplied with the tester, so you obviously get the correct settings and use it as intended. Now the first thing to do of course is connect the correct test leads to the equipment. So we've got the line over here on this red lead, neutral here on the blue, and notice these are on the outgoing side of the RCD, and the earth wire, or earth lead here, which is this green one, of course connects up to the earth terminal up the top here. Now in theory you could test an RCD just by having a current imbalance between the line here and the earth over here, and you wouldn't actually need the neutral, but testers generally have the three leads connected for several reasons, one of which is to make sure you've actually connected these to the correct polarity. Obviously if you connect this to the neutral then the tester won't actually work, and the other reason is so that before the test is actually done it does a check to make sure that you're not going to have any dangerous voltages appearing on the earth to the rest of the installation. Clearly if that say was not connected properly somewhere, just actually doing the test and putting a current between here and here could actually create a fairly high voltage on the earth or other metalwork within the installation. Certainly something which you need to avoid. So that's basically why these testers have the three leads, although of course when the test is done it's simply putting a current between the line here and of course to earth there, so then you've got the imbalance at the device you're testing. Now there's two basic types of tests which you can do on RCDs, and the first one is the current it actually needs to cause the device to trip. And in the case of this particular one it's a 30 milliamp device, so you would expect it to trip at or slightly below that tripping current. And to do this, we'll just select the appropriate setting on here, which is the I delta N setting. And then we just need to select here the correct rating of RCD, so in this case the 30 milliamp variety. And again, we've selected the AC variety there, and there are AC, say, with pulses or DC as well. And you can also do ones with time delay included as well. But in this case, it's just the basic AC variety. So we'll select that. And then the last setting here is either 0 or 180. That refers to the point in the AC waveform at which the testing current is applied, either at the 0 position or 180 degree position, which essentially is either a rising or positive edge or a falling or negative edge. So once we've done those, we can, of course, switch on the power here and just switch on the actual device, and then simply question of pressing the test button. And what will happen is it will gradually increase the current between here and here until the device trips, and then it will just display the actual current that the device tripped at on the front there. So in that case, we've got a current there of 24 milliamps, which is perfectly acceptable. So this is a 30 milliamp device, but 24 is, say, perfectly fine. Generally, you'd expect it to trip between half and the full rating of the device, so between 15 and 30 in this case. So 24, no problems there. Now we should also do this test on the 180 setting as well. So again, we'll just switch on there. And again, it's the same, 24 milliamps. So that's a successful test for that. Most test reports that you would fill in don't actually have a place to complete this part, but nevertheless it's a good idea to actually do this test, certainly on a new device, because of course it's useful to make sure it does actually trip at the current specified. Now the second type of test, and by far the most common one that's done, is the tripping time, or in other words how long it takes to actually trip the device at various test currents. So again, we just selected the delta T setting here, or RCD time. And the other settings are pretty much the same as before. We've got the actual current rating of the device, so 30 milliamps. The type of device, again, just the ordinary AC variety. And we've still got those 0 and 180 degree options as well. And there's three currents which we'll be measuring at. The first one is a half, so in this case that's half of 30, so 15 milliamps. The next one would be 1, so again that's just the 30 milliamps there. And times 5, which would be 150 milliamps for this particular device. And again, there's three of those, and you need to test them at both 0 and 180, so that'll be a total of 6 separate tests. This machine and many others have what's called an auto setting, and essentially that just goes through the 6 combinations of current and 0 and 180, and it means you can just set this up, set it going, and then simply switch the thing back on multiple times, and it will automatically go to the next set of test settings. However, for this demonstration we'll do them all manually because that's a bit more instructive, and as it goes through it will actually, on the auto setting, record all the readings internally so you can scroll through them later. But of course the easiest way is just to write them down with a pen on a piece of paper. So the first test we'll use the half setting, and we'll do that at 0. So again, switch on, and this should not trip. And again, that doesn't trip, and we've simply got greater than 2000 or 2 seconds, so again that was successful. And we need to do it again on the 180 setting, so again we'll test there, and that should not trip either. And once again it did not. So now move on to the 1 setting, which will apply the 30 milliamp test current, and this should trip. And the tripping time should be less than either 300 or 200 milliseconds, depending on which standard the RCD is made to. The more recent one is actually 300 milliseconds. Older ones made to the older BS standard would be 200. But in any case, you don't want to have figures in the hundreds. They should be considerably lower than that. And let's see what this one is. So there we have the result there of 39.2 milliseconds. And again, we'll try that again on the 180 setting. And in that case 26.5. So in both cases that's well within the 200 or 300 in this case setting there, so no problems with that. So then we'll move on to the times 5, which will apply the 150 milliamp setting, and again we'll do that on the 0 to start with. 15 milliseconds, and on the 180 setting 8.5. Notice there is quite a difference between the two settings there, hence why it's necessary to do them on both the 0 and the 180. And for the ×5 setting, the maximum tripping time is 40 milliseconds. So again, 15 and 8.5 are both well within that. Now those are all the tests completed for that particular device, and all of those were a pass. Now you might wonder why it's got this test button on here, and all that does is basically trip the device like that, basically to confirm that it does actually still work internally. Unfortunately, of course, that doesn't really tell you anything about the state of its operation, because it doesn't tell you how long it's taken to trip, or in fact what the test current was. It's purely there so that the end user can do a very basic check just to make sure that the thing does actually work. And if you press the button and it doesn't switch off, then of course the device should be replaced. Now in the majority of installations there should only be a single RCD covering a particular circuit or set of circuits, and for that this particular test setup is absolutely fine. And in some cases there will be another RCD installed on the supply side of the one you're testing, but normally that should be a time delayed variety, so that when testing this one, or if a fault occurs here, it doesn't actually trip the other one further upstream as well. However, there are circumstances, particularly in things like caravan parks and other annoying areas, where you actually end up with two RCDs connected, one here and then one further back on the supply, and unfortunately they're quite often the same rating, so that if you attempt to test the RCD here like this, it's quite likely to either trip this one, or it may also trip the one further up the supply line, in which case that's really annoying, because of course then you can't properly test this one at all. But there's a handy thing to do which can get around this problem, and instead of connecting the earth to the earth here, what you actually do is connect it to the incoming side on the neutral here, and this will still trip this particular RCD no problem, because it's still seeing an imbalance between here and here, obviously on the incoming and outgoing sides, but it won't trip any RCDs further up the chain, because of course according to those they've just got the same current coming in both on the line and the neutral, so they don't actually see the imbalance. Whereas of course if you were testing here on the earth as normal, the imbalance will be seen by both this device and other devices further up the supply chain. And just to prove that this does actually work, if we just select here the say the ×1 setting, and it's saying error there because of course not connected, but if we connect to the neutral side, see the error will go away, and then we can test, and of course it trips just as it did before, so again no problems with that. Notice that the test result here is actually slightly less than we had before. It was 39.2 previously, and it's 36.9 there, and again that's a fairly common situation. It will vary slightly depending on the exact circumstance you're testing it in. Things like sort of temperature and whatever else can affect it, and also how often it's been operated previously. If it had been installed for say 5 years and no one had even bothered to press the testing button for that time, it's quite likely the mechanism might have got a bit sticky, and you would expect therefore it to take a bit longer to trip. But in this case, of course, we've used it several times there, so it may have actually loosened up a bit when we do it. So now see it's doing that 36.9 fairly consistently. And to finish with just a couple of other points to note on the display here, and we've got at the top here UL, which is essentially the maximum voltage allowed to appear on the earth during the test, which in this case is 50 volts. And again, that's why you need those 3 leads connected, because the device will actually check beforehand to see if that voltage would be exceeded, and it won't actually do the test if that was the case. And then down here I've actually got the voltage which will appear there, which in this case is just 1 volt, so pretty much nothing at all. And again, that's just simply the symbol UF here, or the fault voltage. And the other thing this does check for is reverse polarity, so if we were to swap these leads around, for some stupid reason connect the red lead to the blue there, and the blue over here to the line, then it won't actually work. It actually shows here on the display that the neutral and line are reversed, and if we attempted to do the test, well, it isn't going to work. So again, that's just another thing it checks before actually doing the test. Older testers may or may not do that, but certainly the modern ones pretty much all do. So that's testing of RCDs, and of course that should be done every time you've installed a new one, or obviously when doing a check on an existing installation. So until next time, thanks for watching.